Welcome back to the recorded classes for the Information System course. In this class, we will talk about user experience and its design. Our objective during these classes will be to provide some concepts, not the whole picture, because it will be a different profession, but we will provide some concepts about the so-called user-centered design. What does it mean, provide a user-centered design? It means that instead of focusing only on the features of an application, we want to focus on our final users, the ones that will use my system. So, in general, user-centered design means that rules will be defined for the development and the design phases of the whole software process for the development of an information system, and these rules will be added into the development life cycle. So there will be other constraints that will be tailored to providing a better user experience to the final users of the system. When we talk about user experience, we talk about the so-called user interface. What is a user interface? If we consider our system as that gray box, as that gray square, we will have a hidden part of the system that the user doesn't care about, which is the gray background. And we have a smaller part of the system, which is the blue one in the diagram, which is the part with which my user can interact. When we talked about the use case narrative, we had a ping-pong communication between the system and user. And this ping-pong communication happens all through the user interface. In general, this communication will happen through two different things: the inputs, so the actions that the external user does on the user interface, and these inputs arrive to the system, are elaborated in some way. And then, on the other hand, we have the system creating outputs, so answers to the system input. There are many different ways in which we can provide this interaction. And so, if we talk about inputs, we can use different parts of the body. We can use different systems to collect the user's input. So if we want to gather the input from the user by his hands, we can consider the use of keyboards, mouses, touchpads, and a plethora of different devices that have been available since a lot of time. But there are other ways a user can interact with the system. For instance, with his voice, by speech recognition, or by using the eyes, if you think of eye tracking systems that are available, or more recently, there are a lot of sensors that just recognize and register the movement made by the user's bodies. On the other hand, we have different senses that can be involved in reading, in acquiring the responses from the system. We can use our sight to read or visualize some information that is provided by the system. So we can have screens, printers, headsets that will rely on the fact that we can view the results of the system computation. But we can also have audio devices and speech synthesis mechanisms that rely on the hearing sense of the final user. We can also have tactile devices that provide touch output to my users. So those are just a few examples meant to underline that there are almost all the senses can be involved in getting the output from a system, and almost all the parts of a user's body can be involved in providing inputs to the system. So with this kind of meme that we have on the internet, basically providing a good user experience design means that our system will be not only nice and cute to see, but actually it will be easy to use, it will be useful to use without actually providing harm or providing difficulties to the final user. Another very commonly used example about user experience is the typical catch-up battle. So if we focus only on the user interface, we may design a really nice uh, standard glass bottle for ketchup, which is actually nice to see. But if we focus on user experience, we will get a very complete different system, which is this ugly plastic bottle which is flipped bottom up. Why we have a better user experience in the second case? Because actually I bet all of you have experience of using the glass bottle of ketchup, and you need seconds or minutes to have ketchup flow out of the bottle. So even if you have a nicer product, a nicer user interface, the experience that you have with the ketchup bottle is way worse than the second product. The second product, the designers of the plastic bottle, the plastic squeeze bottle, focused on the user experience. So they wanted to provide a system which was more usable, which was easier to use, and which allowed you to have the ketchup faster. And so they designed the system exactly in that way, with the squeeze bottle made of plastic, which is supposed to be stored and shelved upside down. When we talk about a system in general, and this applies to the ketchup bottle, this applies to the mug that can blind you because it is poorly designed. In general, we need to consider different complexities. There are different levels of complexity, different layers of complexity that we need to care when we develop and design a system. First of all, there is a so-called functional complexity. So when we design the user experience, when we design the user interfaces, we need to care about how complex are the functions that are covered by the system. So we, for instance, may have few functions, few features, and we will have instruments with very low functional complexity, or we can have very complex information systems that have many different functions, and they will have a high functional complexity. There is also another complexity, which is the structural complexity. So it is not based on the features that are provided, but it is based, the structural complexity tells how complex is the system itself, how many components I have, how many, if the system is physical, how many pieces I have to connect to create this system. In general, we can create a graph for the structural and functional complexity. So we can have in the x-axis the functional complexity, and in the y-axis the structural complexity. And there are many examples. So if you have a knife, with a knife, typically you can do few things. You can just cut stuff. So it will have a low functional complexity, one function, and it will also have a low structural complexity. A knife is nothing complex in terms of how you have to build a knife. You just have to sharpen some metal, theoretically. Then, if we go to the right, we can consider the Swiss knife. In the case of the Swiss knife, we have a very high functional complexity, because with the Swiss knife you can do a lot of stuff. You can open bottles, you can open wine bottles, or any other kind. You can have the screwdriver, you have a scissors, so many different features. But in terms of structural complexity, it is still something fairly simple. It is just a set of different blades packed together inside a single structure. On the other hand, if we move to the upper left corner, we can consider the clock. And in the case of the clock, we have a very low functional complexity, because the clock is just tells you the time. But in terms of function, in terms of structural complexity, you have a lot of different tiny elements that live inside the case of a clock. It is very difficult to build a clock. And last example, maybe a smartphone, which which has many features, so high functional complexity, and very difficult to build, so very high structural complexity. So with these metaphors we can consider the different concepts, the different layers of complexity for any system when we perform user experience design. Actually, we have, when we talk about user experience, we have a third layer of complexity, which is the so-called complexity in use. So we cannot only think about the complexity of the functions and the complexity of the construction of the device, but we also have to care about the complexity in using the device. The complexity in using the device can make the thing change, because if we look at the graph on the right, in the graph on the right we put now on the y-axis the complexity in use. So in the case of the complexity in use, we flip the graph, because it may be difficult to use a knife properly without harming yourself. And it is even more difficult to use a Swiss knife properly without harming yourself. On the other hand, if we consider the clock and the smartphone, actually, even though they have a very high structural complexity, they are created to be very easy to use. It is super easy to use a clock, and it is actually everyone can be able by now to understand how to use a smartphone. So in that case, we have a very low complexity in use for both the smartphone and the clock. So we see that those systems, even though they may be functionally complex in the case of the smartphone, and structurally complex in both the case of the clock and the smartphone, they are designed in order to have a low complexity in use. So with proper design choices, with proper design focus, we can make even complex functional devices, functionally complex devices, we can make them easy to use. We can make them have a low complexity in use. And so, actually, there are complexity has been studied as a non-functional requirement from long ago. If you remember, we talked about functional and non-functional requirements when we talked about requirements analysis. And actually, there is another dimension, which is the dimension of complexity under the non-functional requirements. So, in addition to the number of features that you can create in a system, you always have to take into account the fact that the system must be easy to use, which also reconnect to one of the technical complexity factors that are part of the use case diagram. And another issue is that many times it happens that from the point of view of the design, the software designers, the software developers tend to over-exaggerate with the number of features that are provided by a system, because it is cool to implement features in a system. Because you are a good developer if your system can do a lot of stuff, a lot of things. The problem is that adding a lot of features to a system may become overwhelming for the final user. If you think of a diesel example, you may have a remote control for a television, which typically is something that you want to use when you get back from work or from university at home, and you are exhausted and you just want to press one button. Maybe you would just want to have a Netflix button and then just 4 buttons to select the movies, and you don't want to think about anything and just relax on your couch. But actually there has been a trend with remote controls, which actually had its peak with the Sky remote controls, which also had DVD reader features or recording features, where we actually had enormous remote controls with hundreds of buttons, and actually it was super complex to understand what to do with which buttons, and the remote controls came with full-fledged manuals to understand how to use the buttons. So actually, when we have a user interface, and in the case of the television system, the remote control is the user interface that the user has, it is important to understand that the user interface has to be simple. It cannot be overwhelmingly complex for the user, otherwise it will be very difficult to use the system. In general, when we talk about making the things simple, we talk about usability and user experience design. So we need to take into account the three dimensions that we have, so the complexity of the system in terms of functions that it provides, the structural complexity of the system, but also the complexity in using the system. We need to think that the functional and structural complexity are in the gray area, so in the gray part of the box representing my system. The blue part is the user interface that I have, and it will be interested by the complexity in using the system. So a good user experience designer must design this user interface in order to provide a low complexity in use and to filter completely the structural and functional complexity of the system. I don't know and I don't care if there are a million different micro elements in my clock. I just want to watch it and immediately know what time is it. And regarding the user interface, of course, the user interface design, the user experience design has evolved over time. So the interaction system has evolved a lot from the 60s to the modern days. So the first systems that we had to interact with computer system and information system were the batch mechanism and the terminals, and we got to the graphical user interface age. And in the graphical user interface age, we had the advent of personal computers, so with Windows in the 90s. Then we started to provide some intelligence to previously stupid devices like phones. So we started having graphical user interfaces for phones, for mobile phones. Then we moved to the internet age and to the so-called interactions age, where actually everything started to be interactable. So if some years ago you could just open and close your fridge, now maybe your fridge has an embedded tablet where you can look at what is the inside of the fridge, or the temperature of the fridge, or have notifications and whatever. So actually by now we live in an immersive, let's say, reality where we have tons of different devices with which we can interact and communicate. In general, there are a few guidelines about user experience design, and the main thing about the user experience design are the user goals. When we design the use cases of a system, we actually are defining these user goals. So the use case design that we have already seen directly translates to the user experience design. So since it is the user using the system, we can understand by thinking about his or her goals what type of devices he will use and what type of information we will have to provide him or her through the graphical user interface. This whole theory about user experience design has been developed by Norman, which is an important theoretical developer about user experience design. His name is Donald Norman, who created this Norman's model. And actually we won't go into the tiny details about the normals model, actually starting from the goal. So the user in his mind forms a goal that has to achieve by using a system. We have the first part of this normals model, which is called the gulf of execution, and which is related to providing an input to the system. So actually, the user, starting from his goal, creates an intention, which is an intention to use the system. Why am I using that system? After that, I need to understand an action to perform on the system. So what is the type of action that I have to perform to interact with the system? Then the third step is actually executing the action. So typing something on a keyboard, moving before a sensor, and so on. After that, the system performs some elaboration, produces some output, and we come in the second part of the normals cycle, which is called the gulf of evaluation. So actually, the user will perceive the state of the world. It will perceive that the system has provided some response. It may be a change in my screen or some paper sheets that exited from a printer. The user has to interpret the state of the world, so interpret what changed, and finally evaluate the outcome, so obtain some data, some information from this changed status of the world. Donald Norman has published this kind of the pillar of the user experience design, and if you're interested into that, there is a very interesting reading by Donald Norman, which is called The Design of Everyday Things, and which is a go-to book for any kind of user experience developer. And it has this funny example of bad design, which is this coffee machine, which actually does what it has to do, because if you put it on your cooking machine, it will actually make your coffee. But actually, if you want to power the coffee into a mug, you will actually burn yourself, or you will power the coffee everywhere instead of only inside the mug. Donald Norman calls this very famous example the masochist coffee machine. In general, Donald Norman is one of the many influential scholars about user experience. Another one is Steve Krug, who created a very famous motto for usability, for user experience, which is "Don't make me think." A very good and usable system will not require me to sit there and try to understand how I have to use a system, but it will automatically guide me to perform correctly the functions with the system and provide the inputs in the correct way. And one example, for instance, another typical example that is used is this device for performing a separate collection of waste somewhere in some Spanish-speaking country. Actually, you can see that this is a super complex system for collecting different types of trash. And so you can see that you have specific holes for putting their CDs, DVDs, and for instance light bulbs, different types of light bulbs actually. So two different holes for light bulbs. Then I have a hole for toners, for cartridges, for printers. Then I have another one for spray cans. And this I don't understand what it is actually, batteries and so on. What happens is that you can see that this is not so successful in terms of user experience, because actually people are trying to stuff batteries into the cartridge hole. So this is a a complex interface, this is an interface which is not clear to utilize, and the result is that not easy to utilize, and the result is that people will not be using it properly. In addition to the usability, it is also important to take into account the feedback. So feedback is something very related to what we said when we talked about web information systems. And actually, it is important that an interface provides feedback to the user. When I have a user interface, it is important that I feel that the system is working and that it didn't freeze while I am performing some operation. So if I type something on a keyboard, I expect that immediately, or at least in some milliseconds, I see the characters on the screen. So it is important that the feedback of a user interface is immediate, or at least quick, so that I don't think that the system is not working. In some cases, when the operations that I have to perform are very long, like when I upload some image or I perform some complex computation, it is very useful to have progress bars, so that I can see an intermediate feedback from a system, and I know that the system isn't dead, but it is doing something, and it will provide me some result in a while. In addition we have seen the usability, so easy of use, we have seen the complexity, we have seen the feedback. Actually, there are, as we said, there are many other dimensions that we won't touch in this class, and actually there is another framework which is called the user experience honeycomb, which is around on the internet, and actually it tells that a proper user interface will need to have many different elements to and needs to fulfill. So it must be usable and useful, so it must provide features and be easy to use. It must be findable, so it must be easy to access this type of input. It must be credible, so it has to be designed in a specific way. It must be valuable, so it has to provide value to the user. It has to be desirable, so we need a bit of aesthetic over there, and it has to be accessible, which is another important thing for user experience. When you think of accessibility, we need to provide our user experience possible for all the impaired people, for instance. And in addition to all these characteristics, there are a lot of different disciplines that are involved in the creation of a user experience. We have the user experience design, which is the specific designing, understanding what the users feel when utilizing a system. We also have, for instance, the information architect, which is the professional in the field of information architecture, which understand how the system is organized in terms of information. And we have the user interface design, which is not completely the same thing as user experience design. The user interface design is related to the interface itself, not to the experience of the user. And finally, we can have the interaction design, which means how the interaction with the user interface is performed. And to make an example, we can think about a way of developing an interface. So we have a running example about traditional and user experience centered way of developing an interface. In the traditional way, we focus on the point of view of the features that we need. So we can think of a lift, an elevator, and we focus only on the features that the system must have. In the case of an elevator, maybe we need to go to a floor N to open or close a door, to stop at some point, or to trigger the alarm. So those are the features of an elevator. In the user experience, in the user-centered design, we instead focus on the use cases. So When we talked about use cases, if we needed to develop the software for an elevator, what are the use cases for an elevator? In this case, we want to call the elevator, we want to enter the elevator, we want to select a floor, stop the elevator, call for help, and exit the elevator. So this part here is a part of functional requirements, which we have seen very briefly in this course. And the functional requirements tell me what the system has to do, what the system can do. The use cases on the other side, tell me what the user can do with the system. What are the goals of the user when they use the system? So starting from the use cases, we can immediately design a user interface. We need to call the elevator, so we will have a button to call the elevator. We need to enter the elevator, okay, we don't need a button to enter the elevator, we just have the doors that open. We need to select a floor, so we will have buttons to select a floor. We need to stop the elevator, we need to call for help, so we have a button for stopping, a button for calling, and then exiting the elevator is actually done with my feet getting outside of the doors. So this is a very trivial example, but actually once you define the use cases, you can start designing the user interface of the system by designing buttons and input mechanism and output mechanism to interact with the system. If, for instance, if we want to complicate and provide even more complicated use cases, we can add the use cases like calling the elevator to go up or calling the elevator to go down. So we create other buttons to create, to execute these use cases. Or maybe we want to open the door or close the door inside the elevator. We create other two buttons to cover these use cases. So as you see, in the trivial example of an elevator, I have my use cases and I create user interfaces to cover these goals. Of course, I can have even interfaces that are not so clear. So for some reasons, they developed these floors, this position in this way. So it is of course necessary to understand the goals, of course, of the user, but also to provide a design of the user interface which makes sense. In this case, there is no, at least I don't know any specific reason for putting the numbers in this position. So maybe there was some reason for that. And another example is from this other content from the internet. Of course, you need to provide buttons that are meaningful and that are correctly described for a user. So your user interface will have to cover the user goals, but also be self-descriptive in telling what you can do. This is an experience that you may have in your that you may have had, especially at grandparents' houses, maybe, where let's say the wiring of a light was not so clear, and you may have multiple switches, light switches all together, and without ever understanding what you had to press. So you just randomly clicked the light switches until you had your result. So without knowing how it worked, you just randomly clicked everything before getting your correct light in your rooms. And so, in general, to get a proper elevator button disposition, to get a proper lighting button disposition, we have to start from the use cases and to provide a human-centered design for the system. In general, this is a kind of cyclic type of operations. So we involve the user in all the phases of my design, in all the phases of my software lifecycle where I design and develop my information system. And so actually we start from this part, we understand and describe the context of the use, so use cases. Then we describe all the user and organizational requirements. We get back to the requirements solicitation. We propose solutions, so we create our mockups and prototypes. Then we validate our prototypes and our proposed solutions. Once we validate our solutions, we have two alternatives. Either the system is fine, and so okay, I can actually produce it. Otherwise, I have to get back and understand what went wrong. There are many different ways to define the requirements with the users. So having the user always in the loop, we say that it is important. There are different ways in user experience design and in requirements involving the user to get all this type of information. Actually, there are many different ways. I am providing the most common ones here with some advantages and disadvantages. We can have questionnaires. It means that I send a questionnaire with multiple choice or open questions to 100, 1,000 of persons. The advantage of doing so is that I can reach many people with low effort, just sending a mail to everyone. The issue is that maybe no one will answer me, so I won't get any result. And the questionnaire must be done carefully, otherwise I get results with no meaning, even if I get any result. I can also perform individual interviews, so I can identify potential users and go to them and ask them for half an hour or 1 hour. The good side of this technique is that if I am good in doing my user experience design job, I can pilot the interview to understand better, to focus, to go deep into some details that might emerge while talking to a potential user. On the other hand, the possibility is that maybe if someone has to talk to me live, it is possible that he is not so confident in providing some possibly personal information or providing some honest information, which is easier to do when you write something on a form. Also, individual interviews require a lot of time and money because you have to pay the interviewers. There is the possibility to create focus groups. Focus groups means that I collect some potential users and I put them all together in a room and they make them talk together to understand and to provide suggestions for the user experience design. The good is that I can have people fight each other to find some agreements, which is always nice, and the solutions are typically shared by everyone in the room. The issue is that it is needed to be expert in that, so that people don't fight each other too much, which can happen. And there is always the possibility that you have some very bold and bossy personality in the room, which will monopolize the discussion and overshadow the opinions of the others. So actually, you will have the result of a focus group which will be coincident with the opinion of a single person. There is another possibility, which is the on-field observation. So instead of asking people to tell me what they want, I just spy them while they are doing the same type of operations in real life. So actually the advantage here is that I understand what is the real use of something similar to what I want to implement. And this actually is a specific understanding of on-field observations. The issues are that it is difficult to perform this type of observation because typically people don't want you to spy them, and they require anyway a lot of time and resources. Finally, I can have spontaneous user suggestions, or at least I can dream of having them, because actually, for instance, when you have a mobile application and you can have the rating and you can provide some feedbacks or some reviews, It is actually useful. The advantages is that it is for free mostly because you get feedbacks from your user, and they can provide very specific details about your system. So, for instance, if I have a screen that crashes, I can have many people telling me, hey, there is a bug in this screen. The problem is that you cannot rely on that because maybe you get no feedback from the users and you cannot only rely on users' feedback. Finally, what is actually done always in any kind of design is analyzing the competitors and the best practices on the market. So you actually avoid reinventing the wheel, you see how the competitors solve your very same problems, and maybe you can do it a little bit better, so obtain a competitive advantage because you see what are the weaknesses of your competitors. The disadvantage is that you need specific people doing this, and it can be costly in terms of time and resources. We have seen that in the human-centered design you typically create a prototype so that you can validate the project against the original requirements. In general, this prototype can be done in different steps. So at the very beginning I can create a sketch, then I can move to something more complicated which is called a wireframe. Then I can create a static set of components which is a set of screen which describes my system, and finally there are the so-called functional mockups. Our objective during this class and the practice class will be try to define the mockups of our system to simulate the functioning of our system. In general, we will work with three different types of interfaces. We can work with web interfaces, desktop interfaces, and mobile interfaces. And in this slide, we already start to see the graphical appearance of the mockups that we will create. There are many issues in the mockup definition, so it is important to understand all the elements of my interface, how they are connected to each other. So, like the buttons in the elevator dashboard, why they were placed that way, how they will be perceived by the user, so are they understandable? Do I have 60 buttons on a remote control and my user feels overwhelmed by it? And I also need to understand what buttons, what elements must have immediate visibility. So those that are crucial because they are related to the most important functions. For instance, if you think of the button for switching on and off a television in your remote control, it is typically red. And it is red because it must have immediate visibility. One of the most important things that you have to do with your television is shutting it down or powering it up, and so the button will be red, because the red is super visible for our brain. And the same for the stop button in the elevator. It has to be red because you have to provide immediate visibility to the user. With our let's say mockups at the very end, with the functional mockups, the immediate next step will be the prototype, which is the final model, the final demonstrative rendition of a planned software system. At that point, I will have the interface of the software system made by a functional system, no longer mockups, and I will provide actual input and output features. So after the mockups, I will create a full prototype of the system. The prototypes of the system will have a life cycle which is very specific, and actually I start with the initial requirements of the prototype. I perform design, the prototypation and the evaluation from the customer. When the customer, as soon as the customer is satisfied, I can say that everything is okay and I can actually produce my system, test the system and then maintain the system. If the customer is not satisfied with the prototype, it is worthless to start implementing the system, so I have to review my prototype and redesign the prototype and recreate a prototype. There are many features of a prototype, so when I want to talk about a prototype, which again it comes after the mockups, it is the final part of the user experience evaluation, I need to evaluate 6 different properties at least. First of all, what is the purpose, what is the objective of the prototype? What is the coverage, so what the prototype covers for the system? What is the fidelity with the system, so how it is representative of the final system? It is super simple or it is super connected to the final system? What is the functional completeness, so how many features of the final system we cover? What is the use that we need to make of the prototype? And how long it will be valid, it will be representative of the system. Without going too much into the details, because this is another discipline, in terms of the purpose of the objective of the prototype, I can evaluate the role of the product. I can evaluate the role of the product in the life of the user, so I can try to understand what will be the role of the system. I can try to evaluate the interface of the system. I can try to evaluate the technical aspects of the implementation of the system. So those may be the purposes of a prototype. In terms of coverage, I can think of global coverage or local coverage. In case of global coverage, I cover the entire system. Of course, it will be very complex to provide a prototype which covers the whole system. Or I can have local coverage to verify a single function or a very vertical prototype focused only on a single use case, for instance. I can talk of fidelity. In case of low fidelity, I have a sketched prototype so that I just can try to visualize something without being representative of the final system. In case of high fidelity, I provide a very detailed prototype, so with working user interface that will be very similar to the final ones. I will simulate all the interactions between the different screens. I will provide a functional model, a mini version of our information system that will give the user the idea of how it will work. In terms of functional completeness of a prototype, without going so much into the details, I can have horizontal functional completeness, so I cover everything. I cover at a high level all the system. I can have vertical functional completeness, so I cover only a single feature in detail. Or I can have diagonal prototypes. I have, for instance, a high-level view, and then I have some verticals below a high-level view. In terms of feature, in terms of usage, how can I use my prototype? I can have a static prototype in which I have a static representation of the product. It is not working, I can just see it and visualize how it will work. This may involve storyboards, diagrams, and so on. Dynamic representation, I can have a video prototype or interactive prototype, so I can have a fully working stuff with, for instance, live mockups and whatever. In terms of durability, I can have 3 different categories of prototypes. Exploratory prototypes, so I do something very sketchy to understand the requirements immediately. It just lives for like half a day. Experimental prototypes, we use it to validate some system specifications and it will work for a while. And operational is an iterative prototype which follows the whole development of the project. Here we have some examples of many forms of prototypes that we can have. So we have seen it in a list before. Now we can see some operations, some operationalizations. So we can have sketches, so drawing of what are the main concepts representing our system. So here, for instance, I have a screen for customers, a screen for trips. I can have storyboards, so still on paper or with some systems, I can define all the screens and connect one with the other through arrows to understand what are the information that I need and how can I move from one screen to the other. And finally, I can have mockups and wireframes. So I can have mockups, which is a little bit more abstract, like on the left, in which I represent all the elements in their disposition in the screen of a system. In the case of wireframes, I use instead the aesthetic of the specific system that we are developing. So this is a very specific example. On the left we have a mockup. This mockup is a very generic representation of the buttons that I will have, and it is valid for any kind of implementation of specific platform on which I implement this system. On the right we have a wireframe, which is maybe it is not so obvious, but in this case it is mimicking an iOS browser setting. So I have a Safari browser where I am running my system, and so I sketch the Safari browser inside this wireframe. So in general, the rule of thumb is that a mockup is general. It is a general representation of the system which is not related to any aesthetic. The wireframe is specific to one of the settings, one of the domains that I will need to cover with my system. I can have also paper prototypes. It is something that it is typically done when user experience is designed. Paper prototypes are typically done in the context of mobile applications design. Another example that I can have is using hypertext prototypes. So I can use PowerPoint with clickable interfaces, or PDFs that are clickable, in which I can have the feeling of clicking on the interfaces. Another technique that I can use is using stencils for hypertext prototypes. So there are libraries on the internet. Those are pretty old actually, because they are related to Yahoo design stencils for Android, but Android of 10 years ago. But in general, there are stencils that can be used in PowerPoint or in PDF creation to create hypertext prototypes. So the last thing that you have to keep into account when creating mockups or wireframes is to understand the so-called user interface grammar. It is the language that we are going to talk when we are defining mockups. So first of all, the first concept is the information architecture. So how the information is organized in my user interface at a very high level. So I can say that in a specific screen of my web page, I have, for instance, my login web page or my login features. Then I have to think about layouts. The layouts tell me how the spaces are organized. So I have a big screen, and the layouts tell me how the individual elements are positioned inside the screen. So layout design will tell me what is the content of each portion of the screen and what is the feature of each portion of the screen. So maybe if you open Facebook, on the central part you have a layout for the content of your friends or the pages that you follow. On the left you have a menu with the buttons. On the right you have the chat. On the upper right part you have the login buttons and whatever. On the upper center you have the search bar, and so on and so forth. The last part that I need to take into account about the user interface grammar is the interaction. So the techniques that I use to interact with the data and which the so-called widgets utilize. The widgets are the components that I use to control my my applications, my mockups. With the widgets, I perform all the interaction that I perform with any kind of application, any kind of web or mobile or desktop application. And there are many different operations that you can perform. Basic one, you can read or display something, or you can insert, for instance, text in some boxes in the screen. You can choose something, think when you are choosing color or nationality in a list. You can search in a search bar, you can filter something on a list, you can provide confirmations, you can navigate, you can move if you have drag and drop interfaces. So you can have multiple interactions on the widgets. The interactions depend on the type of widgets or controls, which is another way of calling them, that you may have. And we can have many different examples of widgets. In this slide, we see the main widgets that we will have in Balsamiq, which is the tool that we are using. We can have buttons and many different formats of buttons, which actually are something that you can click to do something or to move in another page. There are text widgets, and there are many different text widgets. We can have titles, we can have the so-called breadcrumbs, we can have other generic text to visualize some information, links that you can click, text input, so editable text where you can provide some information, for instance your name or your password, blocks of text, so the content of informative web pages, text area input where you have to provide, for instance, the content of an email, or paragraphs with whatever, expandable text, the so-called spoiler. So you have many different widgets that are related to showing text or getting textual input from the user. You also have radio buttons, for instance, for selecting options from a list. You can have checkboxes. The difference between the checkboxes and radio button is that typically in the radio buttons you select just a single one, and in case of a checkbox you can select multiple ones. Or you can have list boxes, meaning that you have a list where you can select something. In the case of the list box, we can have a visible list box, so we just click on one of the items, or we can have a drop-down menu, which in Balsamiq is called a combo box. In general, radio buttons and checkboxes provide different types of features. So in the case of the radio button, I selected just one and only one. In case of the checkbox, I select many. I can select 0 or many. In case of the list box, I can select typically 0 or 1 in this case, or a single one in the last case. And of course, by using Balsamiq, we will see that we will have many other elements like maps, clocks, alerts, playback controls, user logins, charts, date pickers of different formats. So you can color pickers, comments. You will see that we will have many different objects that we can use. Of course, Balsamiq is a tool for mocking up, so it will be super generic, and it has this nice graphic appearance, which is like it was sketched on paper. But if you need to move to the wireframe, you can have widgets for any kind of platform. So you can have widgets for Windows 11, you can have widgets for Java, typical Java applications. You can have widgets for iOS, so mobile devices of the Apple ecosystem. You can have widgets for Android, which is called the material design. So in next classes, live classes, we will see how to use Balsamiq, and we will cover all the different elements of all the different elements of controls and widgets that we can put in a user interface, and we will see how to apply some design guidelines. Just to have a very brief we will follow these UX design guidelines for selecting the controls. And some examples is that if, for instance, you have mutually exclusive alternatives, you use radio buttons. For instance, if you have content that never change and you don't have sufficient screen space, you use drop-down list. So we will get back on this when you can already read them, but you have a set of guidelines that you can use in many cases. So, for instance, if you need to select something that can be represented graphically and mutually exclusive alternatives, you can use palette or calendar selections. If you need to select consecutive data, you may use a combo box or a spin box for selecting numbers, and so on and so forth. We will get back on these guidelines multiple times while doing practice with developing mockups. Other elements, other best practices are, for instance, grouping. So we will group elements together and information together. Typically, if the information are related to the same topic or to the same feature, we can put a box around them so that I know that all those information, all those widgets are related to the same function. For instance, in this case, I see a box for the document information and another box for the author information. So I know that this information here, the name is not the name of the document, but the name of the author, and so on. Again, we will understand and see different operations about layouts. And when using layouts, I need to take into account the hierarchy of the space, because many layouts can be more important than other ones and contain other ones. It is important to understand that each layout will be related to a separate function typically. And another important thing is that I need to take into account the fact that the layout must be adaptable to the screen of the device. So I need to take into account that I may use the same information system on a mobile device or a web device and on a browser, and the layout must be different, because typically on a browser I have a 16:9 representation, scrollable but larger. On a mobile device I typically use it in portrait way, and the visualization must be differently organized. And finally, we will see how to transition from use cases to mockups. So the use cases normally describe round trips between the system and the user to perform a specific user goal. So I need to take all the steps where I have system to user interaction and show the information in my mockups. Then I have to understand what is the type of information that I get from the user and provide controls to input this information. The main requirement, the thing that will be evaluated for the mockups, is that the elements of the graphical user interface must be consistent with the data that is exchanged. So the elements of the mockup will have to be consistent with the exchange between the system and the user in the use case, and also they must be compatible with the data that you have in the class diagram. The secondary requirement is that the UI elements should be used in a correct way, like this, and the usability must be maximum. Of course, and we will not cover this, in the real world there is a load of other stuff, which is related to security, maintenance, performance, scalability, maintenance, and blah blah, and we actually will not cover any of this, because again, there will be, if you are interested, or there will be another different course for user experience development. And in general, what happens is that even if you care a lot about the user experience, typically you can be super careful about designing the user experience, but what happens is that your users will use the system not as you are expecting. Finally, just to see a couple of examples and to close this class, we can, for instance, consider a different, another example of mockup and wireframe. So in this case, this is a mockup of a trip website. We have customers and trips, sorry for the Italian element. And in this case, for instance, we have a very high-level mockup done with Balsamiq. In this case, we have all the information about the people registered in the system, so both customers and trips. And maybe we can have some information about the trips and the locations of the trips, which is shown as a slideshow. So we have pictures that we actually don't have because this is a mockup, and some date picker and some random text over there. When we move to the wireframe, we can create a web application prototype, which is tailored to be a web application. And in this case, I have my customers here and my trips here, and maybe this prototype is already organized to be on a specific browser, and I also provide the look and feel of the final system. So you can move from a mockup, this is an example of a mockup, to an example of a wireframe. And finally, just to provide some pointers, a set of patterns and best practices are the utilization of navigation menus, the utilization of a login and registration specific screen, search and result pages, paging or scrolling, which is for instance what you do on Twitter, the use of data pickers and data inputs, the use of call for actions, so like for instance the GDPR element that you receive every time you open a new website. And using wizards, for instance, to help the users understanding the features, using error messages, and so on and so forth. All these patterns are well documented in the user experience literature. We will see some of them during the examples that we will see in the classes. And in general, there are many different sources and references. You can have the big ones, a book, or if you want to fulfill some curiosity, you can look at the user interface design guidelines, 10 rules of thumb, or some user experience basics that are provided by some organization working on the user experience topic.